This is chapter 1-6, angle pair relationship. Please hit pause to copy your cuts. To begin with definition, vertical angles are angles that are opposite each other when two lines cross or intersect. They are vertical angles because they share the same vertex, and both needs to occur, and two pair of opposite rays will be there. Okay, their angles will be congruent. For example, angles 1 and 3 are vertical angles. Number 1, they share the same vertex. Their vertex that they share, or their union or point of intersection, is point U. So first of all, they share the same vertex, and they have not just one but two pairs of opposite rays. What are the opposite rays? Well, first of all, we have two lines. Line ST is the first line, and the second line is RV. Okay, so first of all, looking at angle 1 and angle 3, they share the same vertex here, and the two pairs of opposite rays. The first pair of opposite ray is what? Remember, pair means you need two. The first pair is for looking here at US. US is the one opposite ray extending upward this way, and its opposite ray, or the ray that's opposite, is UT. Okay, so that's our first pair, US and UT. So US is the first ray, and then we have the second ray, which is UT. Now that's the one pair. The second pair, because we need two pairs, not one but two. Again, they share, angles 1 and 3 share the same vertex, vertex U, and the second pair of opposite rays is going to be ray UV, and then the second will be UR. So again, our second pair of opposite rays will be UV, ray UV. And remember, we start with the initial point, which is the U. UV shooting upward here, and I'm not on the line there. And then the second ray will be UR, which is downward here. UR. Okay, so again, recapping quickly. Vertical pairs will be when you have two lines that cross or intersect. Number 1, for them to be a vertical pair, they must first share the same vertex, and angles 1 and 3 do share the same vertex, vertex U. And at the same time, they have to have not just one but two opposite rays. Okay, the first pair is going to be, if we look here, US, which shoots up this way here, and then UT. Now, going back carefully, when I look at this ray, those rays have to touch the angle. So when I say ray US, does it touch angle 1? Yes, it does. It touches right here on this side leg, right here on this side leg. The opposite ray of US is what? It's UT, going downward. If US touches angle 1, and I'm saying that angle 3 is going to be vertical, that means the opposite ray UT, it better touch angle 3. UT does touch this angle 3, therefore making that the first pair of opposite rays. Well, what's the second pair of opposite rays? The second pair of opposite rays is going to be UV. Here it is shooting upward this way. That's my first ray. Does it touch angle 1 or 3? It touches angle 1. That means that the second ray had better be opposite and at the same time touch angle 3. Well, let's look at UR. UR goes in the opposite direction of UV. It goes downward here, and I'm off the line again. Ray UR, does it touch angle 3? Yes, it does. Just like UV touches angle 1, UR had better touch angle 3, and it does. So we've got two pairs of opposite rays, and then we also have sharing the same vertex. So sharing the vertex U, and then my two opposite rays are going to be US, which touches angle 1, and then we have UT, which touches angle 3. And then my second pair again will be, my second pair of opposite rays will be UV. And this one happens to touch angle 1. And then the opposite ray of UV is UR, and it touches angle 3, therefore making these vertical angles. Moving forward, vertical angles will be congruent. So that means that angle 1 is the same exact measure as angle 3. They are congruent. They are opposite and congruent. So here we have it. Angle 1 and angle 3 are vertical angles. Remember the symbol for angles and the 3 dots, therefore. Angles 1 and 3 are vertical angles, and, therefore their measures are equal. So, if the measure of angle 1 is equal to 102 degrees, what is the measure of angle 3? Because they're vertical angles, that means that angle 3 will also equal 102 degrees. Okay, so the measure of angle 1 is equal to the measure of angle 3. Lowercase cursive m means the measure. I want you to put the number in. Okay, so the measure of angle 1, which we substitute for 102 degrees, is equal to, because it says it's equal here, the measure of angle 3, 102 degrees as well. Linear pair. Linear pairs, and you can put an S in here. Okay. Or a linear pair, just leave it as 1. Let's leave it as 1. Linear pair is when two adjacent, remember the word adjacent means next two angles have an uncommon side. Keyword that you need to pay attention to is the word and. That uncommon side is an opposite ray. A linear pair will equal 180 degrees. Okay, so what do you mean here? I have line TV. Okay, and it's being intersected right here at this ray R, and if I call this point Z, ray RZ intersects the line TV. Alright, here we are with this ray RV. Now, because I have a line TV being intersected by RZ, that means that angles 5 and angle 6 form a linear pair because TV is a line or two rays that go in opposite direction. This TV is a ray, okay, that goes in opposite direction. How is it a ray? Well, if I look at it in two parts, one portion of the ray is RT, okay, RT, ray RT. And although the symbol shoots to the right, if we look at the actual line, remember it shoots upward this way, and I'm off the line. So there's one ray that's going in the opposite direction, and the second portion of that line, looking at it, is RV. So we have the second ray, RV, it goes in the opposite direction of RT. Okay? And there's our second ray. Right, so we can either look at that as line TV or two rays, ray RT and ray RV. They both go in opposite directions of one another. T goes opposite again, as I stated, the direction of V. Since they are linear pair are supplementary, meaning they form 180 degrees, a straight line. So if the measure of angle 5 is 42 degrees, this angle here is equal to 42 degrees. What is the measure of angle 6? Easy breezy to figure or determine. Well, because angle 5 plus the angle of 6, the measure of angle 5 plus the measure of angle 6 is equal to 180 degrees, they're supplementary, we can just write an algebraic equation. The measure of angle 5 plus the measure of angle 6 is supplementary or equal to 180 degrees. We can now substitute for the measure of angle 5. I can put in 42 degrees. I don't know the measure of angle 6, so plus x degrees equals its supplement, which is 180 degrees. Subtract 42 on both sides. We find that x is equal to 138 degrees, and x is represented by the measure of angle 6, which is going to be 138 degrees. Okay? Now looking at angles. Complementary angles, some more definitions for you, are when you have two or more angles and their sum total equals 90 degrees. Supplementary angles are when you have two or more angles whose total sum equal 180 degrees. So complementary 90 degrees, supplementary will equal 180 degrees. Let's look here at example 1. And in example 1, we have this diagram. We have angle, the measure of angle 1, the green angle, plus the measure of the second angle, which is the blue angle, the measure of angle 2 equaling 23 degrees. The question is, what is the measure of angle 1? Well, clearly looking at this whole entire angle, this small angle 1 plus angle 2, the entire whole angle here is equal to 90 degrees. How do I know that? Because of this red marker in the corner. That red box tells me that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. You cannot, just because these two lines, this line here plus this line here, we cannot say they look like they're 90 degrees. If the person writing the problem does not say the two angles equal to 90 degrees, or if they do not put this box in the corner, you cannot say they are 90 degrees. I do not want to hear they look like. You must have a clear determining factor. They either write those two angles equal 90 degrees, or they put this marker in the corner, because it could be 89 and 5/10 degree, and that is not equal to 90. But in this case, they tell us it's 90 with the marker in the corner, meaning 90 degrees. These two angles together, angle 1 plus angle 2, are together complementary or equal to 90 degrees. Therefore, I can write an equation. The measure of angle 1 plus the measure of angle 2, because they're complementary, is equal to 90 degrees. Well, what's the measure of angle 1? Solve by substitution. This is x degrees, okay, plus 23 degrees is equal to 90 degrees. And I want to change this to black here, because everything else is black. So x degrees was 23 degrees. I substituted the 23 degrees in for the measure of angle 2 equals 90 degrees. Solving algebraically, subtract 23 on both sides. X degrees is equal to 67 degrees, and we know that x degrees is equivalent or representative of the measure of angle 1. So now I know the measure of angle 1 is equal to 67 degrees. I can come back here and write in 67 degrees because I've solved it algebraically. Angle 1 plus angle 2 is complementary, 90 degrees, and I know that because of the red box there. In this particular case, it happens to be a red box. Now, let's look at example number 2. Looking at this particular example, again, I see in the corner another box. Again, that tells me that this entire angle from here, this right here, with this right here, those two make a 90-degree angle because of the box I see here. Again, if the box is not there, then you cannot say they're 90 degrees. Or if the problem does not written tell you that all three, angle 1 plus angle 2 plus angle 3 equals 90 degrees, you cannot assume it. It must either say it or have the symbol. All right, and I know it's 90 degrees again because of the symbol. So that means that the measure of angle 1 plus the measure of angle 2 plus the measure of this final angle 3, remember 2 or more angles can be supplementary. In this case, we have 3, or 2 or more angles can be complementary. In this case, 2 or more angles are complementary because they're 90 degrees, not 180. Okay, so measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 90 degrees. And I have 18 degrees plus 22 degrees by substitution. The measure of angle 2 is 22 degrees. The measure of angle 1 is 18 degrees. Plus, I don't know the measure of angle 3. I just know that's x degrees. And I'll come in here and put that is equal to 90 degrees. Solving algebraically, 18 degrees plus 22 degrees is equal to 40 degrees. Plus x degrees here will equal 90. Subtracting 40 degrees on both sides here. And I find that x is equal to, x degrees is equal to 50. And we know that x is representative by the measure of angle 3. So the measure of angle 3 is 50 degrees. And we will be able to go back to the top. And we can now write in here that the measure of this angle here is going to be 50 degrees. And this concludes chapter 1-6.